So this is section 3.1, and now that we're in unit 3, we're going to do two things in unit 3. We are going to graph the trig functions, that's what we're going to start out with, and then we're going to solve trigonometric equations. So we're going to be graphing functions and solving equations. So the first thing we'll do in these first two sections of unit 3 is graph the trig functions. So probably in algebra, you graphed some algebraic functions, maybe like x squared or x cubed, or the absolute value of x, or the square root of x, and you did some graph transformations to them. You moved them up or down, you moved them left or right, or you vertically shrink them, or maybe you horizontally stretch them out, or maybe you flipped them about an axis. Those were called graph transformations. We're going to be doing those to our trig functions graphs as well. But the first thing we need to do is understand the basic trig function graphs first. So before we get into them, we need to know these four things. The amplitude is the height of the wave, or the height from the midline to the top of the wave. So it is a distance, it's always positive. Our sine and cosine graph are going to be these wave functions that are going to go back and forth and back and forth, and they're going to repeat themselves because they repeat themselves every time you go around that unit circle. So they're going to be these waves, and they're just going to keep repeating themselves. So the period is how often we repeat itself. A phase shift is shifting the graph horizontally. So that's moving the graph horizontally. You probably did that in algebra. And then we're going to have a vertical translation. We're going to move it up or down. So we're going to be talking about the amplitude, the period, the phase shift, and the vertical shift, or vertical translation. So before we do any of that, we need to know what the basic graphs looks like. So we're going to graph sine, and I'm going to try and relate it back to the unit circle. So I'm just going to draw the unit circle over here a little bit. And I'm going to cut this graph into 4 points, and that's going to be the quadrantal angles. So I'm going to label these points that would be on the unit circle. So this point would be 1, 0. This point would be 0, 1. This point would be negative 1, 0. And this point down here would be 0, negative 1. Okay, so for the sine graph, we're going to have a period. It's going to repeat itself every 2 pi. So I need to get at least 2 pi on here. And we're going to have points for every quadrantal angle. So I'm going to split this period up into quarters. So here's half of it, and there's a quarter. And notice I'm going to do a few more tick marks. When we graph these trig functions, I want you to at least graph a period. And so here a period is, 4 tick marks because I divided the period into quarters. So half of that would be pi, and then another half of that would be pi over 2. So each one of these tick marks are pi over 2. Pi over 2, pi. This would be 3 pi over 2, 2 pi. This would be 5 pi over 2. The next one would be 3 pi. Then if I went backwards, I would have negative pi over 2, and then I would have negative pi. So again, each of these tick marks are pi's over 2's, and I can count them by pi's over 2's like this. 1 pi over 2. This would have been 2 pi over 2, which reduces. 3 pi over 2. This would be 4 pi over 2, which reduces. 5 pi over 2, 6 pi over 2, and so on and so forth. So we're counting by pi's over 2's, or my tick marks. And this sine graph is going to bounce between positive 1 and negative 1. My midline is going to be on the x-axis. So my midline is right here on the x-axis. I don't normally draw it, I'm just trying to show you. And then I'm going to bounce between 1 and negative 1. So my amplitude for the basic sine graph is 1. I go up 1 from the midline and down 1 from the midline. It's the height of the wave, or the depth of the valley, however you want to say that. And my basic sine graph has a period of 2 pi. So let's draw the basic sine graph. So if we start out, this is x is my angle, and this is the value, my y is sine of x, whatever the sine of that angle is. So sine at an angle of 0 starts off at 0. And we can go through these, and I'm just going to give one little angle as a reference. If I do an angle of pi over 6, the sine value is 1/2. So that's somewhere between 0 and pi over 2. You know, I'm at 1/2-ish. But I'm not really going to normally put that point on here. So at an angle of pi over 2, or 90 degrees, my sine value is 1. And then at an angle of pi, I go back to the midline, my sine value is 0. And then at an angle of 3 pi over 2, my sine value goes down from the midline, it's -1. And then at an angle of 2 pi, I am back to 0. And so here is one period. I'm trying to draw a nice, neat curve. I kind of didn't get through my point right there. There is one period of my sine graph. Sorry about that. I'm trying to cut out the noise. So I want to graph at least one period. So sine starts off at 0 and then it goes up. Sine starts off at 0 and it goes up. That's what I really need you to know about this. Sine starts, S-T-A-R-T, starts at 0, then up. So it goes up, back down to the midline, down, back down to the midline. Now we can repeat this. So at the next tick mark, we're going to be at +1, and then at the next tick mark, we're going to go back down to the midline, and so on and so forth. If we go backwards, we're going down, and then back up from the midline. So something like this. Be sure you put some arrows on the end of your graph, but I want you to graph at least one period. So there's the basic sine graph. It starts at 0 and then it goes up. So now we have this graph, a times sine of bx minus c plus d. So now we've done a bunch of graph transformations on it. The amplitude is whatever the absolute value of a is. That a value in our algebra class, when we multiplied by a number, it vertically stretched or shrank the graph. And I'm going to put flip question mark. If that a value is negative, my amplitude is always a positive number. But if that a value is negative, then what that negative sign did is it flipped it across the x-axis. So maybe instead of going up, it's going to go down first and then up, depending on if that a value is negative. The period, the new formula, is the old period, the normal period, 2 pi divided by whatever b is. Multiplying a number by this x value is going to horizontally stretch it or shrink it, and so it changes my period. And the formula for period is 2 pi over b. Now I always do this thing called tick marks because I want to label my tick marks. And that's how I get my graph. Different teachers do different things. So my tick marks are the period over 4. I'm always going to divide it into quarters. So whatever this new period is, maybe I need to put new period over 4. My phase shift, this minus c part, is what changed the phase shift. It's what moved it horizontally. So the formula for phase shift is c over b. And I don't worry about the signs. This works opposite of how I think it should work. So if this is a negative sign, it's not going to move it backwards, that number. It's actually going to move it to the right, c over b. If that was a positive sign in there, it's not going to move it to the right in the positive direction. It's going to move it backwards to the left in the negative direction. And then the vertical shift is just the plus d part. And this works like you think it should. Works, maybe say works like we think. And again, that kind of comes from algebra. So let's use this unit circle up here, and let's talk about the basic graph for cosine. The amplitude for cosine is normally 1, and it still normally has a period of 2 pi. I'm going to take that period and divide it into quarters. So I'm counting by pi's over 2. 1 pi over 2, 2 pi over 2, which reduces to pi, 3 pi over 2, 4 pi over 2, which reduces to 2 pi, 5 pi over 2, 6 pi over 2, which reduces to 3 pi. I really just need at least one period. I'm going to back this up just a little bit. I'm going to get a little bit more. Negative pi over 2 and negative pi. And then my amplitude, positive 1 and negative 1. Now, if we look at y is cosine of x now, if we look at an angle of 0, my cosine value starts out at 1. So at an angle of 0, my cosine value is at 1. And then at an angle of 90 degrees, my cosine value is at 0. And again, if we look through here at an angle of pi over 6, my cosine value is 1/2. So at pi over 6, we're about at 1/2, if you want to start looking at that. Now at pi, my cosine value is -1. At 3 pi over 2, my cosine value is at 0. And then at 2 pi, I'm back at 1. So here's my minimum of 1 period. You could graph this as a minimum of 1 period. That's fine. Don't make your graph, boxed, sharp corners. Don't do that. It's a nice, neat curve. I'm going to keep going. So I would come back down to the midline and then go back down. And over here, back down to the midline and then down. And so I'm just filling up my whole thing with the graph now. Get you some arrows on the end. I at least have to see 5 dots. So a starting dot and then 4 quarters. So 1, 2, 3, 4, 5. 5 dots will give me at minimum 1 period. But we do the same thing to cosine. We're going to do some graph transformations on that. So that it all works the same as sine. My amplitude is the absolute value of A, and maybe I flip it depending on if it's negative. My period is 2 pi over B. The tick marks are the new period, always over 4 into quarters. My phase shift is C over B, and that's going to work opposite of how I think it should. And my vertical shift is just D, and it works like we think. So lots of information on this page. What I need you to know about cosine is cosine starts at 1 and then goes down. That's what I need you to know about cosine. Sine starts at 0 and then goes up, back down to the midline, down, back down to the midline, back up to the midline, excuse me. Notice at every other dot we're going back to that midline. We're either going up and down to the midline or down and back up to the midline. Same thing here. We're going to start at 1, go down to the midline, go down, come back up to the midline, go up, go back to the midline. Every other dot we're going back to the midline. Cosine starts at 1 and then goes down. Sine starts at 0 and goes up. So let's see if we can graph some of these.